In this lesson, we're really going to crank out some algebra. It has to do with solving rational and radical equations, but these are very process-oriented things, so you need to kind of just learn the process, and then there's a lot of algebra cleanup. So as we get going, first of all, a rational equation is one that looks like a fraction. And these are the steps. So we are going to multiply by the least common denominator. And really, that's going to clear the fractions. Now, if you're not sure what the least common denominator is, we can find that easily by factoring all the denominators. And then you just have to multiply by enough to make them all disappear. If you multiply by enough to make them all disappear, you've done it. Technically, that's going to be all the factors that appear in any of the denominators. And if any of those factors have a power on them, we have to use that as well. But again, the approach we're going to take is factor all the denominators and then multiply by factors until they all disappear. It'll make more sense when you see it. Then, once those fractions are gone, we have this solve by any appropriate method. Well, it really kind of depends, because you could end up with an extremely simple equation left to solve, or you could end up with something more complicated where we need to use a quadratic formula. We're going to have to be careful with parentheses and powers and all of that, but it should be things that we've done before. And I generally call that the cleanup. I'll say, okay, after we get rid of our denominators, we need to do some cleanup and then solve. And then we're going to check your answer. You really should check your answer all the time, but anytime you're multiplying by something that includes a variable, you could end up with what is an extraneous solution. An extraneous solution is a solution that does not check even though you did all the work correctly. So it's kind of an extra answer you just picked up along the way. And we don't expect that to happen, but like x could be -2, but then because you've multiplied by an x, it becomes a positive number. And to just make sure we didn't pick up negatives when we didn't need them or something like that, we've got to check our answers. All right, so we're going to start applying this. Again, the big trick here is multiplying so that our denominators go away. This one's going to be real simple. As we look at this, typically we wouldn't have to factor this, but because that's the approach we're going to take in general, I am going to write that down underneath. 6 factors into 2 times 3. So that means I can multiply all of these by a 3. And I'm just going to write it up here at the top. And now those 3's cancel. But I haven't gotten rid of all my denominators. So I also need to multiply by a 2. And now this 2 will cancel. But as you can still see, I have an x there. So I'm going to multiply all of them by x. And now that x will cancel. So now we're good to go on the cleanup. What is left? Well, on this first one, I have 2x. And then on the second one, I still have a minus out there. What's left here? I have a 5 and an x. And then on this last one, it's 3 times 2, which is 6. So again, when it's just a plain number, rather than factor that, I could have just said, what's the common denominator for 3 and 6? And you guys would have known, really, that it's 6. But the process in general is going to be factor. So you can see what's left here is not really a difficult one for us to solve. So this is our solve by any appropriate method. Combine those like terms. I have -3x equals 6. Divide both sides by -3, and x equals -2. So now I'm going to check that. 1/3 minus 5/6, does it in fact equal 1/2, which that's -1/2. So you could use a calculator to help you with that, but using a common denominator here, this is 2/6 minus 5/6, which is -3/6, which is -1/2. So that one checks. So this is my answer. When you go to type this one in, unlike before when we were doing an axis of symmetry, the answer is really the -2, not the full equation. So you're just going to put the -2 in the answer box there. All right, So here we go again. We need to factor. The second two denominators don't factor, but the first denominator factors into x plus 3 and then x minus 3. All right, so now I have it factored. So now we need to multiply so that all those go away. So for this one to go away, I have to multiply by x plus 3, x minus 3. You can't do it to any one of them. You have to do it to all of them. It doesn't so much matter where we write. I'm going to write them behind it this time. X plus 3 and x minus 3. X plus 3, x minus 3. X plus 3 and x minus 3. All right, now what cancels? X minus 3 cancels with x minus 3 on that one. X plus 3 cancels with x plus 3 here. And both of them cancel on this very first one. So all of my denominators have canceled now. So now I'm going to write down very carefully what's left. So I ended up with a 2 plus 5 times x plus 3 equals 3 times x minus 3. This is where we move into that solve by any appropriate method. So first of all, my cleanup, I want to simplify this so far as possible. So I've got to distribute and all of that. So 2 plus 5x plus 15 equals 3x minus 9. I'm going to collect my like terms here. So this side will be 5x. That doesn't look like an x, does it? Plus 17 equals 3x minus 9. If I subtract 3x from both sides, I'll get a 2x over here on the left. And if I subtract 17, negative 9 minus 17 more is negative 26. Divide both sides by 2, and x is negative 13. So I believe that's my answer. I'm going to check. Negative 13 squared is 169 minus 9 is 160. And I have plus 5 over. Negative 13 minus 3 more is negative 16. And I'm going to check and see if that equals 3 over negative 10 when I plug that one in. So now this one is just going to be easiest for me to pull up my calculator and do a quick check. You just want to make sure that that left-hand side equals the right-hand side. Alpha y equals, enter, 2 over 160. And then I have plus a fraction that has 5 over negative 16. Now typically I would bring that minus out to the front and just say minus 5/16, but I'm going to try it just like it's written there. So I get negative 3/10. So yay, it checks. And again, we're expecting them to check, but you just need to watch out for that possibility. So negative 13 is the answer there. This one's just got a little bit more factoring. Factor of 5 to the front. So now that one's factored. This one is x plus 1, x minus 1. And that last one doesn't factor. So I need to multiply all of these by 5 to get the 5 to cancel, an x plus 1, and an x minus 1. All right, 5 cancels, x plus 1 cancels, x plus 1 and x minus 1 and then x minus 1. All right, so what does that leave me? On this very first one, I have a 2 and an x minus 1. Yeah, I could distribute at once, but I find that trying to do too many steps at once can actually lead to mistakes. So here I had a minus in between them. Don't lose your negative. And there was a 3 to begin with, but now I need to multiply it times a 5, so that's a times there. Both of those have gone away, equals 4 times 5 times x plus 1. Okay, so now clean that and crank it out. I'm just going to kind of write it down as I go and not slow down too much because I think you guys are fine with this. That's 2x minus 2 minus 15 equals, I'm distributing really at 20, so that's 20x plus 20. So this time I like to move things to my larger x term. I'm going to subtract 2x from both sides, which will give me 18x over here on the right. And then negative 2 minus 15 is negative 17. But then I also have to subtract another 20. So that's going to be minus 37, or negative 37. All right, divide both sides by 18, and I would have negative 37 over 18. They are the same. So see, I've used my calculator to check by just typing in my left and right after I've stored it into x. So this one did check, and that's my answer. Moving to a different type of problem. The other type was radical equations. So here are our steps for radical equations. Raise both sides of the equation to the power that effectively undoes the root. So if it's a square root, we're going to square both sides. If it's a cubed root, you're going to cube both sides. Okay? Now you don't want to do that until you get a radical by itself. Most of the time there's only going to be one radical, but there could be two radicals in your equation, at which point you can only get one of them by itself at a time. Then we're going to raise both sides to the power that gets rid of the radical. If you do happen to still have a radical in there, then you would repeat that process. Then once that radical's gone, we solve by any appropriate method. You can see that I forgot to work the previous problem for you on that screen, so I've just inserted a slide here that shows I squared both sides and then solved, as well as doing the check. The only thing on the left-hand side of this equation. So at this point in time, what we're going to do is just take both sides of this equation and raise it to the fourth. What that does over here on the left is it essentially marks off that fourth root in the fourth, and we get x squared minus 1. And then 1 to the fourth is 1. Boy, that equation is a lot simpler, isn't it? So then x squared is equal to 2. So x is equal to the positive or negative root 2. So I have two different answers here, the positive root 2 and the negative root 2. Do they both check? Okay, so you would want to make sure they check, and I could do that orally, but I think for most of us it's easier if we're just looking at a calculator as it goes along. So again, I'm going to put in the square root, second squared, there's the square root of 2, and then I'm going to store that into x. And by the way, you don't have to get it in decimal form first. I could have just taken the square root of 2, get out from underneath that radical, and then hit store that into x. Now it does change it into decimal form. That's still going to work for us, because now I can type this left-hand side, which is the fourth root. So you might think, well, how do I put in a fourth root? If you go to math, see this option 5 has that little x there. That's the one you want. That means you can use any root you want to. It has a third root already built in, but we can use option 5. And now I can put in the fourth root. Okay, now older calculators, you needed to go ahead and type the 4 and then choose that. But if you've got the newer calculator, it's going to do that for you. So we've got x squared minus 1. So now that's that left-hand side, and it's already stored that as x. So I can just check, and it equals 1. But I also need to check the negative root. So I'm going to do the negative square root of 2 I'm going to store that into x. Now, rather than retype that left-hand side of the equation, I can just go back up, hit enter, and it recalculates, and it's still a 1. So both of those values checked. So I have two answers, square root of 2 and the negative square root of 2. Now this one has two radicals in it. So that's what I was saying. If you want to do something like this, first of all, you have to get one of those radicals all by itself. Now there's no exact rule as to which one it needs to be, but I can tell you the one that's the ugliest is the one we generally want to get rid of first. So before I actually square both sides, I'm going to get this radical by itself. So that's going to leave me, if I first of all take the square root of x over, I end up with 1 minus the square root of x. You could leave this negative here and deal with it, but generally when we say isolate, it means get it entirely by itself. So I'm just going to go ahead and do that. X minus 5 equals, and I'm dividing both of these by negative, which means I get negative 1 plus the square root of x. Okay, now that we've got the radical by itself, you want to take both sides of your equation and raise it to the power of this radical. Now I'm focusing in on this left one because it's the one that's by itself. It's the only one we're really going to get rid of in this step. So when I square both sides here, on this left-hand side, it simply undoes that square root, and I get x minus 5. But on the right, and for some of you, you're going to be like, grown, unfortunately, these are two terms here. So this is like I'm needing to FOIL it out. If you need to, write it out again. Negative 1 plus root x times negative 1 plus root x, and then FOIL. I'm going to use a pattern, though. When you have two terms and you square it, you get the first term squared. Then if you multiply the terms and double it, it will give you the middle. So if I multiply those, I get negative square root of x, and I double it, I get negative 2 square roots of x. And then the last term squared just gets rid of that square root, so we just have x. But again, if you don't know that pattern, you could just do negative 1 plus root x times negative 1 plus root x and use FOIL. Now I still have a radical. So what I need to do is get this radical all by itself. So before I do that, though, I can't combine like terms. If I subtract x from both sides, that's kind of beautiful because the x here on the left cancels with this x on the right if I subtract x from both sides. And I can subtract 1 from both sides, and that will give me negative 6 equals negative 2 root x. Again, I'm trying to get that radical by itself, so I can do this again. So now if I divide both sides by negative 2, I'll get 3 equals the square root of x. So you can see this one's going to actually clean up pretty nicely for us because now I'm ready to square both sides to get rid of that radical. And I end up with 9 equals x. So now I want to check it. Not the only way to check. I don't mind you just plugging it in. I'm just trying to show for those of you that aren't as comfortable with just checking it in your head. If you can take 9 and store it into x. Now I can type in this left-hand side of the equation. So I end up with the square root of x. Get out from underneath the radical, minus, and then again we have the square root, and it's x minus 5, and then enter, and it equals 1. So that checks. You may or may not be familiar with this sort of format, but this is a radical. So the very first thing, just to kind of give you a rule to go on, if you have a radical, whatever that root is out here, and I'm just going to kind of write it down differently, and then I don't even care what that is, so that's just a scribble, blah, 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 blah. Then you have a power on it. That is the same thing as having that scribble raised to the p over r. So the denominator, this 4 here, is the root. And this 1 right here is a power. So you don't have to rewrite it, but sometimes it's helpful to people as they're learning it to say, okay, so that's the 4th root of t to the 1st. Of course, t to the 1st is just t. But this means the exact same thing. So whether or not you rewrite it or not, it's this 4 we're trying to get rid of. And the way that we get rid of that is by raising both sides of the equation to the 4th. So if we had left it in its fraction form, we would have just let those 4's cancel and we would have had t to the 1st. But that still happens with my rewrite. So I end up with t to the 1st is equal to 3 to the 4th. 3 to the 4th is 81. So now I want to check that one out. Even though that's a t, I'm certainly going to use an x when I'm on my calculator. I could use other letters. There's tons of other letters on here, but it just takes longer to type and it doesn't make any difference. Okay, so you can just use a different variable. So now it's stored that in there, and now I can take my x and raise it to the 1/4. And I get 3. So this checks. Often we use the solving principles to get a different variable by itself. And so here, this is in this section because these are fractions. So we have fractional equations. We can use that same principle of let's get rid of all the fractions and then let's get what we want by itself. It's not the only way to rearrange them, but that is why it's included in this section. So on this very first one, if I want to get rid of the fractions, then I want to multiply both sides by t sub 1 and t sub 2. Now, the t sub 1s are going to cancel here on the left, and the t sub 2s cancel on the right. Once you get rid of the fractions, to finish this process, what you want to do is isolate whatever variable they told you to solve for. So when it says solve for whatever, that's when you're trying to get that variable by itself. So if it says solve for a smiley face, then you're trying to get your equation to read smiley face equals. So this one says 4t sub 1. So I want to get t sub 1 equals. So this is where I need to focus. This is what I'm trying to isolate and get by itself. So what do I need to move then? I need to move the other things that are over here with it. Since they are multiplied, I'm going to move them by division. And then those cancel. And my result, you can write it either direction, but t sub 1 equals p sub 1, v sub 1, t sub 2 over p sub 2, v sub 2. You're wondering what all these out. These are actual equations that are used in other applications. I think that the one on the left has to do with a gas, so that you're talking about the amount of pressure and the volume and the temperature. Okay, the pressure, the volume, and the temperature of a gas are all related. And so this has to do with the gas. Now, this one has to do, I think that F was force and the M is mass, but I can't remember where these equations came from. But again, if we're going to use this principle, same principle, if we have to solve it for another one, the very first thing you want to do is just get rid of the fractions. So I'm going to multiply here by F, M, and P. And then we cancel what we can cancel. So F cancels, M, and P. And that leaves me with MP is equal to FP plus FM. Now looking at what I'm supposed to solve for, I want to get F by itself. but I have two terms with an F in them. So what I'm really going to need to do is kind of collect that F by factoring it out. So undistributed. And now we can look at it and say, okay, if I want to get the F by itself, see, I had two terms. Now I have it into one term. I want to get it by itself. Then I want to look at that and say, well, then I need to divide off this P plus M. And then we have our answer. So you got a couple of those things in your homework too. These are just two more because they involve radicals. Same sort of thing. We're going to use the same principles we did before to get rid of the radical. Then we will focus in on what we are supposed to solve for. So first of all, since that is a squared root, I am going to square both sides. And I get W squared is equal to 1 over LC. So now I'm trying to solve for C, but you're not going to be able to say C equals while it's in a denominator. So the very next thing I need to do is actually use my previous thing to get it out of the denominator. So I'm going to multiply by LC on both sides, and it cancels. So now I have LCW squared equals 1. Well, I'm trying to get C by itself because it said 4C. So since I'm solving for C, then I want to divide off this L and W squared. So now I have C, because the L's cancel and the W squares cancel over here, so I have C equals 1 over LW squared. Last example, we're going to square both sides. That's going to go away, so I have S squared equals A over 6. I'm wanting to get the A by itself, which really means this one's going to be a lot easier. You don't have nearly as much work to do. I just need to multiply both sides by 6. And then A is equal to 6 S squared. So we use the same principles even with letters. That finishes up this video. Hope this helped.